Tibetan Plateau, where the earth touches heaven and rivers are born to quench half the world. Not the largest landmass, but the highest plateau on Earth. The Tibetan Plateau rises above the clouds at an average elevation exceeding 4,500 meters, a vast expanse of 2,500,000 square kilometers, where human civilization has thrived in conditions that would seem impossible elsewhere. Often called the roof of the world, this extraordinary geographic feature sits at the intersection of Central, South, and East Asia, stretching approximately 1,000 kilometers from north to south and 2,500 kilometers from east to west. Its northwestern Changtang region reaches even more extreme heights, with average altitudes exceeding 5,000 meters. This is not merely a geographic curiosity. The Tibetan Plateau serves as the water tower of Asia, the source region for the continent's most vital rivers including the Yangtze, Yellow, Mekong, Brahmaputra, Indus, and Salween. These waterways provide life-sustaining resources to over 1.35 billion people, approximately 1/5 of humanity. The plateau contains over 46,000 glaciers covering 105,000 square kilometers, representing the largest reserve of freshwater outside the polar regions, and earning it the designation Third Pole. More than 10 million people call this extreme environment home, including ethnic Tibetans, Sherpa, Chang, Tamang, and other communities who have adapted to life at elevations where oxygen is scarce and temperatures are brutal. The plateau's highest point, Mount Everest, reaches 8,848.26 meters above sea level. This massive elevated landform exerts profound influence on Asian and global climate through its thermal and mechanical forcing on the atmosphere, affecting monsoon systems and weather patterns across the Northern Hemisphere. It is a place where geology, hydrology, climate, and human culture converge at the top of the world. The story of the Tibetan Plateau begins approximately 70 million years ago in the Upper Cretaceous period, when two massive tectonic plates set a collision course that would fundamentally reshape Asia. The Indo-Australian plate, moving northward at approximately 15 centimeters per year, began its inexorable journey toward the Eurasian plate. This was not a sudden impact, but a slow-motion collision of continental proportions, a geological process that would unfold over tens of millions of years. About 50 million years ago, the fast-moving Indo-Australian plate completed a momentous transformation by completely closing the Tethys Ocean that had once separated the two landmasses. The sedimentary rocks that had accumulated on the ocean floor were compressed and crumpled upward, creating massive mountain ranges including the Himalayas, Kunlun Mountains, and Karakoram. The plateau itself comprises several different continental plates, known as terranes, including the Kunlun, Songban, Yangtze, Changtang, and Lhasa terranes, which were progressively accreted to the southern continental margin of Asia throughout the Phanerozoic eon. The uplift occurred in stages rather than continuously. Evidence suggests the plateau's mean elevation was around 3,000 meters above sea level around the Oligocene-Miocene boundary, approximately 23 million years ago. Between 25.5 and 21.6 million years ago, the plateau actually fell by 900 meters before subsequently rising by 500 to 1,000 meters between 20.6 and 20.4 million years ago. The central plateau was elevated by 40 million years ago, while major uplift began in the early Miocene. The plateau probably reached its present elevation by about 8 million years ago. Remarkably, this process continues today, with the Indo-Australian plate still being driven horizontally beneath the plateau, causing it to rise at approximately 5 millimeters per year. Chapter 3: Extreme Environment and Climate. The Tibetan Plateau exists in a realm of climatic extremes that challenge both life and landscape. Annual precipitation varies dramatically across the region, with the northern and northwestern areas receiving a mere 100 to 300 millimeters per year, creating conditions approaching those of cold deserts. Annual average temperatures range between 5.6 and 8.8 degrees Celsius across most of the plateau, but the Changtang region in the northwest experiences far harsher conditions with average temperatures of minus 5.6 degrees Celsius. During the late Paleogene period, before reaching its current elevation, Tibet consisted of a deep Paleo valley bounded by multiple mountain ranges, a dramatically different landscape from today's elevated expanse. The plateau's extreme altitude and vast extent create powerful effects on atmospheric circulation. Its elevated surface acts as a massive heat source during summer and a cold surface during winter, driving thermal forcing that influences monsoon systems across Asia. The mechanical barrier it presents to atmospheric flow shapes weather patterns throughout the Northern Hemisphere. This is not a stable, unchanging environment. The plateau is warming at approximately 2.2 degrees Celsius per decade, roughly twice the global average rate, making it one of the most rapidly warming regions on Earth. Human presence in this extreme environment extends far back into prehistory. Archaeological evidence suggests the earliest human occupation occurred between 30,000 and 40,000 years ago, with hardy populations adapting to the thin air and brutal conditions. Today, approximately 40% of the ethnic Tibetan population maintains traditional nomadic pastoralist lifestyles, moving their herds across the high grasslands in patterns refined over millennia. These communities have developed unique cultural practices, architecture, and survival strategies suited to life at the top of the world. The designation, Third Pole, reflects a reality that extends far beyond metaphor. The Tibetan Plateau contains the world's third largest store of ice after Antarctica and Greenland, with over 46,000 glaciers covering an area of 105,000 square kilometers. These frozen reservoirs represent the largest concentration of fresh water outside the polar regions, a critical resource in an increasingly water-stressed world. The glaciers feed 7 of Asia's greatest rivers, each a lifeline for hundreds of millions of people downstream. The Yangtze River, Asia's longest, originates on the plateau and flows 6,300 kilometers to the East China Sea. The Yellow River, Cradle of Chinese Civilization, begins its journey here. The Mekong sustains communities across 6 Southeast Asian nations. The Brahmaputra carves through the Himalayas before joining the Ganges. The Indus provides water to Pakistan and northwestern India. The Salween flows through China, Myanmar, and Thailand. The Tarim River feeds the desert oases of western China. Together, these river systems provide water resources to over 1.35 billion people. The plateau supports unique ecosystems adapted to extreme altitude and harsh conditions. Montane grasslands cover vast areas, providing grazing for wild ungulates and domestic herds. Alpine tundra exists in the harshest zones, while monsoon-influenced shrublands and forests occupy lower elevations and more favorable aspects. Endemic species found nowhere else on Earth have evolved to survive in this environment of low oxygen, intense solar radiation, extreme temperature fluctuations, and limited precipitation. The plateau harbors biodiversity hotspots of global significance, though many species face threats from climate change and human activities. This ecological importance complements the hydrological significance, making the plateau a critical region for both natural systems and human societies across Asia. Chapter 5: Crisis at the Summit. The Tibetan Plateau today stands at a critical juncture, facing environmental changes that reverberate far beyond its boundaries. Over the past 5 decades, 80% of the plateau's glaciers have retreated, losing 4.5% of their combined aerial coverage. This represents not merely the loss of ice, but the shrinking of Asia's primary freshwater reservoir, with profound implications for the 1.35 billion people who depend on plateau-fed rivers. Permafrost, the permanently frozen ground that underlies much of the plateau, is degrading at accelerating rates as temperatures rise twice as fast as the global average. The warming plateau alters atmospheric circulation patterns that have remained relatively stable for millennia. Changes in the timing and intensity of monsoons affect agriculture across South and East Asia. Reduced glacier melt threatens dry season river flows, while accelerated melting in the short term increases flood risks. The plateau's role as a climate regulator is being compromised precisely when it is needed most. Beyond climate impacts, the region faces pressures from mining operations, extracting valuable minerals and metals, dam construction projects altering river flows, and increasing human activity in previously remote areas. Yet the plateau retains its cultural and spiritual significance. The Tibetan Empire that flourished from the 7th to 9th century AD left a legacy visible in monasteries like the Potala Palace in Lhasa and the Jokang Temple. Sacred mountains like Mount Kailash continue to draw pilgrims from Tibetan Buddhism, Hinduism, Jainism, and Bon traditions. Traditional knowledge accumulated over thousands of years of high-altitude habitation remains vital for understanding how humans can adapt to extreme environments. The roof of the world, the third pole, the water tower of Asia. The Tibetan Plateau bears many names, each reflecting a different dimension of its global importance as it faces an uncertain future. The formation of the Tibetan Plateau fundamentally transformed the hydrological architecture of the entire Asian continent. As the landmass rose to its current elevation, it created the source region for 7 of Asia's greatest rivers, the Yangtze, Yellow, Mekong, Brahmaputra, Indus, Salween, and Tarim. These waterways, born from the plateau's glaciers and snowmelt, cascade down from the heights to nourish the lowlands below. The designation, Water Tower of Asia, captures a profound reality. More than 135 billion people, approximately 1/5 of the world's population, depend on water resources originating from this elevated region. The Yangtze River alone provides water for over 400 million people in China, while the Indus supports the agricultural heartland of Pakistan. The Mekong sustains communities across 6 nations in Southeast Asia. The plateau's uplift created massive mountain ranges that serve as natural water towers. The Himalayas to the south, the Kunlun Mountains to the north, the Karakoram to the west, and the Hungduan Mountains to the east all function as barriers that capture moisture and store it as ice and snow. This frozen reservoir releases water gradually throughout the year, maintaining river flows even during dry seasons. The hydrological influence extends beyond immediate water supply. The plateau's rivers have carved some of the world's deepest gorges, created vast fertile deltas, and shaped the agricultural civilizations that arose along their banks. The silt carried by these rivers has built alluvial plains that support some of the highest population densities on Earth. Without the Tibetan Plateau's sustained water release, much of Asia's agricultural productivity and urban development would be impossible. Chapter 7: Atmospheric Engine of the Hemisphere. Scientific investigation has revealed that the Tibetan Plateau functions as a massive atmospheric engine, exerting profound influence on climate patterns across the Northern Hemisphere. The plateau's elevated surface acts as a heat source during summer months, creating thermal forcing that drives atmospheric circulation on a continental scale. This thermal effect fundamentally shapes the Asian monsoon system, which delivers life-giving rains to billions of people. The mechanical forcing created by the plateau's physical presence is equally significant. As air masses encounter this vast, elevated barrier, they are deflected, channeled, and lifted, creating weather patterns that extend thousands of kilometers beyond the plateau itself. The plateau influences the jet stream, affects the intensity and timing of monsoons, and even impacts weather systems over North America through atmospheric teleconnections. Research conducted over the past half-century has documented the plateau's warming at approximately 0.2 degrees Celsius per decade, roughly twice the global average rate. This accelerated warming has become a critical focus for climate scientists seeking to understand regional and global climate change. The Changtang region in the northwest, where average altitude exceeds 5,000 meters, and annual average temperature hovers around -5.6 degrees Celsius, serves as a particularly sensitive indicator of climate shifts. Scientists have established monitoring stations across the plateau to track changes in temperature, precipitation, permafrost, and glacier dynamics. These observations reveal complex feedback mechanisms between the plateau's surface conditions and atmospheric processes. Changes in snow cover, for instance, alter the plateau's albedo, its reflectivity, which in turn affects how much solar energy is absorbed, creating cascading effects on regional climate. The plateau has become a natural laboratory for understanding high-altitude climate processes and their global implications. The Tibetan Plateau has nurtured human civilization for millennia, with archaeological evidence suggesting earliest occupation between 30,000 and 40,000 years ago. The extreme high-altitude environment demanded extraordinary adaptations, shaping unique cultural practices that persist today. The plateau became the heartland of Tibetan culture, religion, and one of the world's most distinctive civilizations. The Tibetan Empire, which flourished from the 7th to 9th century AD, represented one of the most powerful states in Central Asia. At its height, this empire controlled vast territories and engaged diplomatically and militarily with Tang dynasty China, the Abbasid Caliphate, and kingdoms of South Asia. The empire's legacy established political and cultural patterns that endured for centuries. Tibetan Buddhism emerged as the dominant spiritual tradition, transforming the plateau into one of the world's great centers of religious learning and practice. Monasteries such as the Potala Palace in Lhasa and Jokang Temple became architectural marvels and spiritual focal points. Mount Kailash, standing at 6,638 meters, became sacred to multiple religions, including Buddhism, Hinduism, Jainism, and the indigenous Bon tradition. The plateau's inhabitants developed nomadic pastoralism as a sustainable adaptation to the harsh environment. Approximately 40% of the ethnic Tibetan population continues this traditional lifestyle, herding yaks, sheep, and goats across vast grasslands. These pastoralists developed sophisticated knowledge of seasonal migration patterns, animal husbandry, and resource management suited to the extreme conditions. The plateau is home to diverse ethnic groups beyond Tibetans, including Sherpa, Chiang, Tamang, Loba, Mompa, and communities of Han Chinese and Hui Chinese. Each group has contributed distinct cultural elements, languages, arts, festivals, and traditions, creating a rich cultural mosaic. Traditional arts such as Thangka painting, distinctive architectural styles, and unique musical traditions reflect centuries of cultural development in this elevated realm. Chapter 9: Biodiversity at the Extremes. The Tibetan Plateau's unique environmental conditions have fostered remarkable biodiversity, creating ecosystems found nowhere else on Earth. Despite the harsh climate, with annual precipitation ranging from just 100 to 300 millimeters in northern and northwestern areas, the plateau supports montane grasslands, alpine tundra, and monsoon-influenced shrublands and forests. These ecosystems harbor species with extraordinary adaptations to extreme altitude, low oxygen levels, intense ultraviolet radiation, and dramatic temperature fluctuations. The plateau's fauna includes iconic species such as the Tibetan antelope, wild yak, Tibetan wild ass, snow leopard, and Tibetan brown bear. Many of these animals have evolved specialized physiological adaptations, including enhanced oxygen-carrying capacity in their blood, allowing them to thrive at elevations where most mammals would perish. The Tibetan antelope migrates across hundreds of kilometers of the Changtang region, one of the longest large mammal migrations in Asia. The region's avian diversity is equally impressive, with numerous species of high-altitude birds, including bar-headed geese that migrate over the Himalayas at altitudes exceeding 7,000 meters. Black-necked cranes, considered sacred in Tibetan culture, breed in the plateau's wetlands and marshes. The plateau's plant life demonstrates remarkable resilience. Alpine meadows dominated by hardy grasses and sedges provide crucial grazing for both wild and domestic herbivores. Medicinal plants used in traditional Tibetan medicine grow in these extreme conditions, some found only at elevations above 4,000 meters. However, this biodiversity faces mounting pressures. Climate change is shifting vegetation zones upward, fragmenting habitats, and altering the timing of seasonal events that wildlife depends upon. Mining operations, infrastructure development, and dam construction are transforming landscapes that remained relatively unchanged for millennia. Conservation efforts now focus on protecting critical habitats and migration corridors, recognizing that the plateau's biodiversity represents an irreplaceable natural heritage with global significance. Today, the Tibetan Plateau stands as both a monument to Earth's geological power and a sentinel warning of accelerating environmental change. Its multiple designations, Roof of the World, Third Pole, Water Tower of Asia, reflect its unparalleled significance to human civilization and planetary systems. The plateau's 2,500,000 square kilometers, stretching approximately 1,000 kilometers north to south and 2,500 kilometers east to west, influence the lives of billions. The contemporary challenge facing the plateau is unprecedented in human timescales. Over the past 5 decades, 80% of its glaciers have retreated, with a combined loss of 4.5% of their aerial coverage. The 46,000 glaciers covering 105,000 square kilometers are shrinking at accelerating rates, threatening water security for downstream populations. Permafrost, which underlies vast areas of the plateau, is degrading as temperatures rise, releasing stored carbon and destabilizing infrastructure. Yet the plateau remains home to over 10 million people who continue traditional livelihoods and cultural practices. Tibetan communities maintain spiritual connections to sacred mountains and lakes, practice centuries-old agricultural and pastoral techniques, and preserve knowledge systems developed over millennia of high-altitude living. The scientific community has elevated the Tibetan Plateau to a priority research region for understanding climate change impacts on high-altitude environments. International collaborations monitor glacier dynamics, permafrost conditions, ecosystem changes, and hydrological shifts. The plateau's response to warming provides crucial insights into feedback mechanisms that affect global climate systems. The legacy of the Tibetan Plateau extends beyond its physical dimensions. It represents a confluence of geological forces, climatic processes, biological adaptation, and human culture that together create one of Earth's most extraordinary regions. As the Indo-Australian plate continues pushing beneath Eurasia at approximately 5 millimeters per year, the plateau continues rising, a reminder that the forces that created this realm remain active. How humanity responds to the environmental changes now transforming the plateau will determine not only its future, but the fate of the billions who depend on the waters flowing from the roof of the world.